Today's lesson is on trapezoids and kites, so we'll start with the trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Of course, if it had two pairs of parallel sides, then it would be a parallelogram, right? And the parallel sides of a trapezoid are called its bases. A trapezoid has two pairs of base angles. Each pair shares a base as a side. This would probably be a good time for me to draw a trapezoid here so I could point out what I'm talking about. Okay, so the parallel sides are here, so those are the trapezoid's bases. The base angles are here. I'm not going to mark those as congruent. They might be congruent in a minute, but I'm just going to label them. So 1, 2, 3, 4. So the pairs of base angles are angle 1 and angle 2 and angle 3 and angle 4. Those are the base angles. The non-parallel sides, so that would be this one and this one, those would be the trapezoid's legs. And a trapezoid with congruent legs is an isosceles trapezoid. And of course it's going to look like this. Of course the bases are still parallel and that leg would be congruent to that leg. Okay, and that leads us to our first theorem related to trapezoids, and that says if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So in my figure that I have right here, I know that angle A is congruent to angle B, and angle D is congruent to angle C. Both pairs of base angles are congruent. All right, so let's just put this into action and solve a couple of problems. Find the measures of the numbered angles in each isosceles trapezoid. Well, of course, I know the measure of angle 1 has to be 49 because it's congruent to that other base angle there. And what about, I know that the measure of angle 2 equals the measure of angle 3 because that's a set of base angles. And I know that 1 and 2 are going to be supplementary, right? Because they're consecutive interior angles. 1 and 2 are supplementary. So since 1 measures 49, the measure of angle 2 is going to be 180 minus 49, which equals 131 degrees. And so, of course, that's the measure of angle 3 as well. All right, why don't you pause here and do this next one and check back and see if you got the right answer. Okay, that was a simple matter of knowing that the measure of angle 1 is 105 because angle 1 is congruent to angle X. And then, of course, 2 would be supplementary to 1, and 3 would be supplementary to X, so both of those would have to measure 75 degrees. Okay, we got another theorem. It says if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So AC is going to be congruent to BD, and that's what I'm going to try to prove here. AC, I probably should have listed this AC, I should have called this BD here. Oh, and also on your paper, I think I made an error here. So be sure to correct this. The legs are AD and CB, and those are the legs that are congruent. Okay, so here we go. Make sure you got these things corrected. Let's put down our statements and our reasons. And of course, we'll start with the given, just like always. Isosceles trapezoid ABCD with AD congruent to CB. That's given. Okay, and here's what I think is going to happen. Now this is a good place for us to stop and think, how am I going to show that those diagonals are congruent? I think what I'm going to have to do is find myself two congruent triangles, and then AC and BD will be corresponding parts of those two congruent triangles. So let's head off down that path. So this is congruent to this. So here's what I'm thinking. I'm thinking that I need to get this triangle right here, the green one, and I need to somehow show that it's congruent to the red one, right? And then those diagonals will be corresponding parts. So if you want to pause here and finish this for yourself, it's not a difficult proof. It would be good for you, but I'm going to roll on forward here. And what I'm going to say now is that DC is congruent to CD. Because that side, this side right here, is shared between the red and the green triangles. So what I'm going for here, I've got two sides now. So that's good. That's two sides of the triangles. So, and what's that? That's going to be the symmetric property. Symmetric property of congruence. And now I'm going to use the theorem that I learned just today that tells me the base angles of an isosceles trapezoid are congruent. So angle ADC is congruent to angle BCD because of the theorem base angles of an isosceles trapezoid are congruent. That's not too much to write, just write it, don't complain. And so what have I got? I have congruence now, right? I've got side angle side, side angle side. So triangle ADC is congruent to triangle BCD. That side angle side. And then finally, I'm going to say my diagonals are congruent because they're corresponding parts of those congruent triangles. So AC is congruent to BD. Corresponding parts of congruent triangles are congruent. Alrighty, so there we have proved our theorem. Okay, now we have a segment. The segment in a trapezoid that connects the midpoint of its legs is called its midsegment. And if you remember, we had a midsegment of a triangle too, and it did the same thing. It connected the midpoints of two sides of a triangle. So trapezoid has a midsegment too, and we have a theorem here about the midsegment. If a quadrilateral is a trapezoid, then number one, the midsegment is parallel to the bases. So here's our midsegment, MN. It's parallel to the bases, so I'm going to mark it as such. And number two, the length of the midsegment is half the sum of the lengths of the bases. So the length of the midsegment is half the sum of the lengths of the bases. So that's what we got there. So let's put that into action here with a little example. QR is the midsegment. What is the measure of X? Okay, what did the theorem just tell me? It told me that the midsegment is 1/2 the sum of the bases. So 4x minus 10 plus 8. All right, I'm just going to multiply both sides by 2 first to get rid of that 1/2. And let's see, that's going to give me 2x plus 4 equals 4x minus 2. And I'll get my 2x on the right and my negative 2 on the left. So let's see, 4 plus 2 is 6, 4x minus 2x is 2x, so that tells me that x is 3. Let me just plug that in to make sure I didn't make some kind of computational error. 4 times 3 is 12, 12 minus 10 is 2, and if I plug 3 in here, that would be 5, and sure enough, 5 is half of 2 plus 8, so good job. All right, let's see what else. Oh, we're going to switch off now. We've done enough of trapezoids. We're going to talk about kites now. What is a kite? It's a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. And here you just thought it was a thing that you flew outside on a windy day. Okay, we have a kite theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. Don't think congruent. Clearly they're not congruent. The diagonals are perpendicular. Okay, so what are we going to do? We're going to prove, oh, here's what we're going to prove, is that these angles here will always be congruent in any kite. So we're going to use this example here to prove this. Okay, statements, reasons, kite ABCD with AB congruent to CB and CD congruent to AD. That's given. Okay, well, once again, what I think I'm going to have to do is show that the top triangle in this kite is congruent to the bottom triangle, and then those angles will be corresponding parts, right? Well, we've almost got it. We've got two sides, so we can just say that BD is congruent to itself, right? BD is congruent to itself, and this time I do want to use the reflexive property. BD is congruent to BD. Let me double check. I'm going to go BCD, BCD, A. Hold on a second. Actually, nope. Nope, I need the symmetric property again to name these in the proper order. So BD is congruent to DB, symmetric property. And now I've got my triangles. Triangle BCD is congruent to triangle BAD, triangle bad, and that's by side, side, side. Side, side, side congruence. And now I can say that angle BCD is congruent BCD BAD, angle BAD. And that's because they're corresponding parts of congruent triangles. You know what, guys? I'm going back to my original thought. I do need the reflexive property here. My apologies. It's early in the morning, having trouble waking up. BD is congruent to itself. That is the reflexive property. I know most of you were saying, wait, she was right the first time. Reflexive property of congruence, because if I'm looking at the order, B, C, D, back to B, and then I go B, A, D, back to, yeah, so it's definitely BD is congruent to BD. And what did I erase here? CD is congruent to AD, and triangle BCD, BAD. So there we go. I think that's got it, guys. Keep an eye on me. All right, what are we going to do now? Some practice. We just got a few practice problems. Okay, and remember, don't forget what we just proved is that these two angles here in the kite are congruent because they'll be corresponding parts if I were to divide that into two triangles. So let's see what we're going to do. We know, let's do 37 and 73, and that gives us 110, right? So we know that angle S and angle U have to be, I know that it's a quadrilateral, so I know the sum of all the angles is 360 degrees, right? The sum is 360 degrees. So if I take 360 and subtract the 110 that are angles V and T, I get 250. So I know that 250 is the measure of angle S plus the measure of angle U, and I know that those two things are congruent to each other. So the measure of angle S equals the measure of angle U, which has to be 125 degrees. All right, what do we have next? If AC is 38 and ED is 41, find CD. Okay. Okay, I had to pause for a second here. I had my mind stuck on trapezoids and I was looking at this, forgetting that it's a kite. I think we should have said somewhere here that this is a kite. Should have been in the problem. So anyway, what I have here is that AC is 38. Okay, what happens is this diagonal, the short diagonal in the kite, will be bisected by the other diagonal. So I know that, what is that letter? E. I know that EC is 19. Each part of AC is half of 38, so 19. And then they're telling me that ED is 41, so all I really have here is a right triangle that I have to solve, and CD is the hypotenuse, so CD squared equals 41 squared plus 19 squared. So CD is going to be the square root of 41 squared plus 19 squared. Whew, I need my calculator for that, and I don't have it on me right at the moment, so you all can punch that in. I do not think that's going to be a triple, so you're going to need to simplify that radical there. I'm going to let you do, well, hold on, I'll do it and I'll come back and write in the answer. Okay, well, I've been trying to find a perfect square in 2042 and it eludes me. So if you found one and simplified this radical, great. Please tell me what it is tomorrow when we come to class. Okay, what have we got now? Let's see. Oh, 3 more problems. So what I'm going to do is let you work these and come back and check your solutions. Our next lesson will be on quadrilaterals in the coordinate plane. That will be the last lesson in our unit on polygons, and we will see you then. All right, here we go. I'm going to talk you through this first one. It took me a second, actually, because I think I was trying to find the measure of angle FGH, and I really could not figure out a way to do that. But what I'm really looking for is this angle right here. And what I have to do is look at this in terms of this little right triangle right here. All right, so what I know is that this diagonal, since it's the perpendicular bisector of this other diagonal, then it also bisects this angle here. It bisects angle F. So to start out, I got to say that 5x minus 1 equals 2x plus 11. And then I find out that x equals 4, so I can find out that this angle here is 19 degrees. Okay, and then I look at my little red right triangle, and I just add 19 and 90. 19 and 90 gives me 109, and so then I just need to subtract that from 180 to find out that angle FGH measures 71 degrees. Okay, down here we just use the trapezoid mid-segment theorem to find out that x equals 4. And finally, we use the properties of kites to find the measures of all these angles, and also using the fact that the diagonals are perpendicular. All right, see you next time.